So let me know when you guys want to start.
I'm good whenever.
Okay.
Yep, ready.
Sounds good. I'll just read it. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z 1.358 and to the left. Oh, that's easy.
Yep.
I just have to find, where's that link again for the applet curve?
If you just Google normal probability app, it's like the first thing that shows up.
Okay. Sweet. So it says we just need to do it 1.358, 1.358, and then the normal area is just in the middle, right?
Well, it
Yeah.
says to the right of the 1.358 and to the left of the negative 1.358.
Okay.
So it's the two sides, not the middle.
Yeah, thank you. So the area, I got 0.1745.
Yep,
Yeah.
me too.
Okay.
So 3 decimal places, 0.175.
Mm-hmm.
Yep.
Perfect.
Which other questions were that easy?
I know, me too.
Okay, so for the United States Coast Guard assumes that the mean weight of passenger in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weight of a random sample of 48 passengers was reported. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is an extreme or more extreme, either above or below the mean that was observed in this example. Note, as extreme or more extreme means that we are not only interested in the values that are lower, than the ones we observed, but also the values that are as far away from the mean as we occur in our positive direction.
Is Sarah calling you guys?
No.
Oh, I just got a video call from her, but I don't know how to add her.
I sent her a request.
Okay. She was just calling me, so I didn't know.
Because I don't know if you would like accept it, that would take you off of ours or not.
Yeah, that's why I was scared to accept it.
Yeah, maybe she'll just check her email and see.
I hope so.
Because I don't know how to like add. Well, I just added her. I could have sworn I did. Let's see. Sorry, I'm just trying to do this at the same time.
Oh, you're good.
Mm-hmm.
Okay, so how do we start with that one question? I'll multitask right now.
Hold on, I'll try to figure it out.
Yeah, that's what I'm just trying to do right now, too.
Okay. So we just do the standard deviation, right? First.
I'm not sure.
Mm-mm.
Because I just did like from last week's, because I just did 185, like the mean minus the average, the sample mean.
Hmm.
So 185 minus 177.6, and then divided by 26.7, and I got 0.277.
So, but are we like basically looking for the z-scores like on each side,
I don't
or
know.
just okay?
Yes. Oh my gosh, sorry.
Oh no, you're fine.
I do not know what happened. Okay. Which one are you guys on?
4. We just barely started on 4.
Okay.
I think we might have to do a square root of something.
Right now I'm just working on that equation where z equals the mean minus the sample mean divided by the deviation divided by the square root of n.
Because I was looking, because that's what I did. Oh,
Yeah.
we were talking about dividing by the square root, because the equation that I see is like z equals, shoot, what is it? What is that number? Hold on a second.
So let's see.
Because I'm looking on the the book that explains it, and because
Yeah.
the sample is x minus the mean over um, standard deviation divided by square root of 4.
Yeah, so what
Hmm.
I did is I did that equation, and I got the z-score to be 1.92, and then I plugged that into the applet and took the two ends and added those together, and I got 0.0549.
That makes sense.
Does it make sense?
Yeah, so what did you say you added the what together at the end?
So I plugged the z-score into the applet, the 1.92,
Okay.
and so it says it wants you to find the probability of above the two extremes, either above or
Okay.
below the mean. So I went above the 1.92, and then I went below the negative 1.92. But I'm not sure if that's correct.
That makes sense
On
though.
the applet, then you just did both sides, right?
Yeah, that's what I did.
So you got 0.055.
I got
Yeah.
0.0, yeah, 55. Yep.
Yeah, that makes sense. So you did like the normal equation and then you divide it by the square root of whatever it was.
48.
That makes sense. I
Okay.
found this lesson really confusing.
Yeah, it was a little confusing. Me too. I mean, that makes sense what you're saying.
Yeah, I hope it's right.
I'm fine with that answer because that makes sense.
Yeah, me too.
All right, sounds good.
Okay, so for 5, which of the following will have which will have a smaller standard deviation if 9 observations are randomly drawn from a population?
I said individual, but I don't know if that's right.
Hmm. I think it would be the sample means one, because if it's all from the same population, the means will be similar, I guess.
Yeah.
And you want the smallest standard deviation. So if you do all the means, they'll all be like, I mean, they're all means, so they're all pretty close to the same, I think.
Yeah, I read that wrong. I think it's sample means too.
Because it's kind of like the first question, the number 4, right? Just kind of like if you do it, the means is always smaller.
Yeah.
Okay, that makes sense. So 6, for which of the following results implies that the spread in X decreases as the sample size increases?
I think that one, the law of large numbers.
That's what
I
I
feel
said.
like I saw that somewhere.
Yeah, I said large numbers too.
Okay. So we're gonna move on?
Yeah, that's probably what I'll go with. I mean,
Okay.
if you guys have a question, I mean, we can go over it again, I guess, but
But
that's
that does
what
make
sounds
sense.
familiar to me.
Yeah. Okay, so scores of the quantitative portion of the GRE are approximately normal distribution with mean 150.8 and standard deviation 8.8. So Diane earns a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score?
So I did this one. I think I just did the equation where it's like the value minus the mean divided by the standard deviation, then plug that in.
Mm-hmm.
Yeah.
0.148. But again, math, not my strong point.
Are you on 7 or 8?
7.
Because I got 0.148 for 8.
Okay.
And 7 I got 1.045.
So I did.
Yeah, and don't we plug that in? That's what I got for 7, 1.045. And don't we plug that in for the area?
Yeah.
Yeah.
Yeah,
And
you plug that in for the area for the z-scores, and then it gives you the area.
And then would we just say it's just the normal, it's not less or above, right? The highlighted part?
That's what I did. I don't know which part to highlight on the applet.
Yeah.
I guess it would be
What'd you guys get for the z-score? Sorry.
1.045.
that's what I got too, so I guess I just didn't highlight the right part.
Okay. So
Because if you did it in the middle, which I did, I got, for the area, I got 0.704.
so are we still on number 7? Or are we on 8?
We're still on 7.
Okay, good.
You just did the middle.
So what's in? Do we know what? We don't know what that is. So how did you guys get the z-score?
So we just did the normal equation where it's the normal minus, I mean the score, like the highest number, so like 160 minus 150.8 divided by the standard deviation.
Okay.
So what did you get when you plugged it in for the area?
I got 0.704.
Yeah, that's what I got too if you did the middle part.
Because it's just normal, right?
I think so, because it's not above or below, and that's what.
Because it would specify that.
Yeah, and her score is. Yeah, I think so.
Okay. I mean, I'm fine with that answer.
Yeah.
Mm-hmm.
Okay, so for 7, it's 1.045. And for, is that what you guys said?
Yeah, so then for 8, it's the same exact, which you just change the shading to above, I think, the positive z-score.
Yeah, you just go to the right, and then it's the 1.148.
Yeah. Okay.
Yeah. Okay, that makes sense.
Okay, so then you guys got the 0.148. Okay.
Yeah.
you.
So for 9, are we on 9 now?
Yeah.
Yeah.
Okay. So I averaged out and I got 160. And then the z-score was 1.045 because it was the same thing. But
hmm
again, I don't know.
Yeah, I got 162.
Okay. That's just the same equation, but it's just the z-score, so it's just 1.045.
Yeah, I think so.
So like that's really easy, but okay.
1.045. So then for 10, I think you just do the above the 1.045, which we still got the same answer.
hmm
Yeah, because that is above.
It would be the same answer as 8, 0.148, right?
Because it's above. Yeah, I think so.
Yeah, I think so.
Okay.
I hope we're right.
Yeah.
Okay.
Let me know when you guys are all good to move on.
Good.
I'm good.
Okay.
Yep.
So suppose the mean GPA BYU Idaho students is 3.5 and the standard deviation is zero point 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81 will be drawn. What is the shape of the sampling distribution of this random variable x, which represents the sample mean of the 81 students who are selected?
Well, I said normal because I thought if it was above 30 because of the law of something that was normal.
Yeah, that's the same that I got. Just because it's such a big sample size, it makes it even
Normal.
out.
Yeah.
Okay.
Yeah.
The next ones I could not get.
What is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population?
For that one, I just put 3.5 because, like, right above it, it says the mean of the GPA of Idaho students is 3.5. So I think no matter who you take the sample from of the 81 students, the mean is still the same,
Yeah,
Okay. Yeah.
as far as I can tell, at least.
that makes sense.
This seems so easy. Yeah.
So what is the standard deviation of the sampling distribution of the random? So wouldn't that just be 0.7?
I don't, because it's random variable x. So then isn't that just any of them too?
I think to find what they're asking for there, you have to use the that equation of like the standard deviation over the root of n. So on that one, you'd have to do the 0.7 divided by root of 81 because there's 81 students.
Oh, because then it could represent any one of them.
Okay, so then I got for 0.7 divided by the root of 81, I got 0.078.
Yep.
Yeah.
But we were just doing 2 decimals, right? It says
3 decimals.
3, okay. 0.78. So then what is the probability? So that makes sense, right?
Yeah, I think
Okay.
so.
14, what is the probability that the mean of the GPA for 81 randomly selected students would be less than 3.3?
Would we just do that same one with 3.3 minus mean over standard deviation and do the one on the left on the applet? Does that make sense?
So do you find But in order to find the z-score, you have to have two means. So would you just do 3.5 minus 3.3?
I think it's 3.3 minus
Yeah,
3.5.
value minus mean over the standard deviation, which is 0.7.
Can it be negative though?
Yeah. Well,
Yeah.
because if you get a negative z-score, it just corresponds to
Oh yeah.
inputs in the same one but positive, and then you just pick the left tail of it.
0.7. Okay, so I got negative 0.286 if I rounded.
Yeah, negative 2.86. That's what you got,
Yeah.
2.286.
Mm-hmm.
Then you put that into the applet, and then
You just do the left side.
Yeah.
Got 0.387.
Wait, what did you guys get for the z-score?
0.286.
I got negative 2.57.
Oh, good. Me too.
Oh, did you do 3.3 minus 3.5
Yeah.
divided by 0.7?
0.7 divided by the square root of 81.
Oh, yes.
oh, okay.
So that gives you the negative 2.57. And when you put that in, you get 0.005 for the area.
Okay.
Yeah.
Glad you got that.
What was the z-score you got for that?
Negative 2.5714.
What was the area?
2.5. You have to do that specific number or whatever. Just do it. And then what was the area you got?
The left tail is 0.005.
Okay, yeah, that's what I got.
And then for the next one, because it's greater than 3.3, it's just 1 minus that, so it's just 0.995.
So it's greater than.
Because the number 15 is just asking what is the probability that it'll be greater than 3.3, and the last one was asking what is it, well, it'll be less than 3.3.
Yeah. And
So if
you
you
do
just
that on
do,
the applet, it's the same thing because you just unhighlight the left side and do the rest.
exactly, if you
So
just
they-
highlight the other two, you get 995.
Okay, I got that too.
Awesome. What did you guys get for number 3?
0.175.
That's what I got.
Okay, so for 3 we got 0.175, 4 0.055, 5 the distribution of the sample means, 6 the law of large numbers, 7.704, 8.
Wait, what? Seven's what?
7 is 0.704.
0.704.
Yeah.
Oh, I had 8 and 7 mixed up. Okay.
Okay, and then 8 is 0.148. 9 is 1.045. 10 is 0.148. 11 is approximately normal. 12 is 3.5. 13 is 0.078. 14 is 0.005. And then 15 is 0.995.
Mm-hmm.
Sounds good. I'm just going to submit it and see.
That's fine.
We just missed 9 and 10.
So somehow we got our mean wrong on 9.
Yeah.
Wait, what did you put for 7 again?
I guess
0.704, I guess.
that's what I
Okay, so that was wrong too, right?
Yeah.
Okay.
How did we get that wrong? Because we
Well,
got.
I don't know why, but I had plugged in there 1.0455, but
Oh,
I
you
don't know.
did?
I did, but I thought that's what we said.
Oh, that was the Z score.
Oh,
We
we
put
weren't
the
supposed to-
area.
That's
Oh,
you gotta step
Oh, that's what
farther.
we did.
okay. That's okay.
Yeah, because it was asking the z-score, but I guess we put in the area.
I think we did the wrong equation for 9.
What did we do?
All right. Well, I gotta take off for work. I gotta leave right now. So
Okay,
I'll see you guys on Tuesday.
cool. And then
See
I'll
ya.
post the link. I'll post the link.
Okay.
You.
Okay, see you guys on Tuesday.
Yeah.
Alrighty.
See ya. Bye.